Section 1.8 is Algebra of Functions and Function Composition. So first of all, we're going to perform operations on functions. This is just what it says it is. If you add two functions, you add two functions. F minus g of x is the same thing as f of x minus g of x, just subtracting them. Same thing with multiplication and division. So let's go ahead and look at some examples. I'm going to try to use some color coding here. So f plus g of x is the same thing as f of x plus g of x. Okay? And so that is just f of x, which is x squared minus 3x plus 1, plus g of x, which is the square root of 8 minus x. Now, if we had any like terms here, we could add, but we don't. So that is your answer. Here, f minus g of x, that's f of x minus g of x. So f of x is x squared minus 3x plus 1 minus g of x, which is 8 minus x. And if there wasn't that square root there, we would have to put it in parentheses and distribute. But since it is, there's nothing we can do. That's the end of it. F times g of x is f of x divided by g of x. So we've got x squared minus 3x plus 1 divided by the square root of 8 minus x. Now, this one has something we need to do to it, because we can't have a square root in the denominator. So, in order to get rid of a square root in the denominator, remember we multiply both the top and the bottom by a square root of that, which is h minus x here. So in that case, on the bottom, we're just going to get 8 minus x. On the top, we're multiplying everything on the top by the square root of 8 minus x. So we've got x squared times the square root of 8 minus x minus 3x times the square root of 8 minus x plus 1 times the square root of 8 minus x. And that's as far as it can go. Oh, we were supposed to multiply there? Crap. Okay, well, there's the division one. We'll just put that over here. If I can get it to. There we go. Fixed. So, f divided by g of x is f of x divided by g of x. Now let's go back over here, and we're multiplying. F of x times g of x. Okay, so f of x is x squared minus 3x plus 1, and g of x is square root of 8 minus x. So this time we're also going to distribute through the square root of 8 minus x. So we've got x squared times the square root of 8 minus x minus 3x times the square root of 8 minus x plus 1 times the square root of 8 minus x, which is just the square root of 8 minus x. Okay, so done with that. Moving on, this one says we have f minus g of negative 8. Well, there's two ways you could do this, okay? You can find f minus g of x and plug in negative 8, which we've already done that. So let's just look at this and see what we got here. Okay? So that's our first option. Okay, and so we could plug in now -8 everywhere. Square root of 16 is 4, and we get 85. So that is one option. Okay, or we can say f of -8 minus g of -8, and plug it in right from the beginning. So we would just say -8 squared minus 3 times -8 plus 1, and then minus g of -8, which is 8 minus -8, and we get the exact same thing as when we did the other, 85. So either way you choose to do, you might find this method a little bit quicker, but then if you've already found f of x minus g of x, you could just plug in. Sometimes when you found f of x minus g of x, it's smaller than plugging in over to the left. In this case, there weren't like terms when we found it. So, okay, this one is g times h of 0. So we've got g of 0 times h of 0. Okay, so g of 0 is 8 minus 0. And we're going to multiply that by h of 0, which is 2 over 0 plus 1. 8 minus 0 is just 8, so we've got the square root of 8 times 2 over 1. So it's just 2 square root of 8, or to simplify 8, that's 2 square root of 2, because we would have 4 times 2, and the square root of 4 is 2. So it's actually 4 square root of 2. And then the last one just wants us to find h of -1. Okay, so 2 over -1 plus 1 gives us 2 over 0. Well, you can't divide by 0, so h of -1 is undefined. And we've got a few more examples here. So r minus t of x. That would be r of x minus t of x. Notice how I put t of x in parentheses because we have to distribute. So we've got x squared minus x. Oh, I've done something wrong here. I thought it was supposed to be plus 4. Minus 1. r divided by t of x. That's r of x divided by t of x. That's all we can do. Oh, we're supposed to find the domain too. Okay, back here, the domain of this is a quadratic. It's a parabola. So the domain is just negative infinity to infinity. For this one, the domain is everything except for where the bottom is 0. So we can't have x plus 4 equal to 0. So x cannot be negative 4. So the domain would be negative infinity to negative 4, unioned with negative 4 to infinity. For C, we have s times t of x, so that's s of x times t of x. So that gives us 2x plus 8 over x. So again, the domain here is everywhere except for where the bottom is equal to 0, so x cannot be 0. So the domain is negative infinity to 0, unioned with 0 to infinity. And the difference quotient. This is something that we include in 171 because we'll be using it in calculus, basically. So we're just sticking it in here for a little bit of introduction to it. The expression f of x plus h minus f of x over h is the difference quotient. Okay, so let's look at an example. So first it asks us to just find f of x plus h, and then we're going to plug into the difference quotient. So f of x plus h would be 5 of x plus h minus 2. So 5x plus 5h minus 2. And then it wants us to go and plug that into the difference quotient. So the difference quotient is f of x plus h minus f of x over h. Okay, so we've got x, our f of x plus h, which was 5x plus 5h minus 2. And then minus f of x. So we got to put this in parentheses, and f of x was 5x minus 2. And then divided by h. So we end up with 5x plus 5h minus 2 minus 5x plus 2 over h. Notice something here. 5x minus 5x, it goes away. Negative 2 plus 2, it goes away. And we're just left with 5h over h. And then the h's cancel. So we're just left with 5. And that's how you plug in for the difference quotient. So let's look at one more example. Here, f of x plus h is x plus h, quantity squared, minus 3 times x plus h, plus 8. Okay, so x plus h quantity squared, that gives us x squared plus 2xh plus h squared. And then we have minus 3x minus 3h plus 8. And there's nothing there, actually, that can be combined. So for our difference quotient, we have our f of x plus h minus f of x. Oh, I did the wrong color. over h. Okay? So our f of x plus h was this. And then minus f of x, which was x squared minus 3x plus 8. And that's all divided by h. And we've got to distribute that negative there. So minus x squared plus 3x minus 8 all over h. And notice yet again we have things that go away when we combine like terms. So we've got 2xh plus h squared minus 3h over h. Notice on the top, you've got an h in every term. Where did my... Okay, so we can factor out an h on the top, and that makes these h's cancel, and we're still left with one, but that's okay. So 2x plus h minus 3 is your answer. Okay, our last concept today, we're going to compose and decompose functions. So to compose a function, it's f dot g. Now that is not a multiplication dot. That's saying of, okay? So f dot g of x is f of g of x. What that means is everywhere that there's an x in f, we're going to plug in what there is g of x. You'll see in the example. Okay, so f dot g of x is f of g of x. Okay? That is f of g of x. That's 5x plus 4. And so what this means for us to do is in f, we're going to plug in 5x plus 4 everywhere there's an x in f. So here where there's an x squared, we're going to put 5x plus 4. And then minus 3 times 5x plus 4. And then plus 1. And then we just simplify. So 5x plus 4 squared, that's 5x plus 4 times 5x plus 4. So 4. And that gives us 25x squared plus 40x plus 16. Then distribute the negative 3, so that's minus 15x minus 12, and then plus 1. And then we're going to combine like terms, and that's it. Okay? So that's how you compose functions. We've put them together. The next problem wants us to find g of f of x. So that's g of f of x. So g of f of x, which is x squared minus 3x plus 1. So in g, we're going to plug in x squared minus 3x plus 1 whenever we run into an x. So we've got 5 times x squared minus 3x plus 1 plus 4. Then distribute the 5 inside our parentheses and combine like terms. Okay? Let's look at one more example like this. So f of g of x is f of the square root of 5x plus 5. So whenever we run into an x in f, we're going to put the square root of 5x plus 5. And the square root of 5x plus 5 squared is just 5x plus 5. Distribute. And we have 25x plus 24. Then g dot f of x is g of f of x. So g of f of x is 5x squared minus 1. So we've got the square root of 5 times 5x squared minus 1 plus 5. So we can distribute inside our radical here. The 5's go away, so we get the square root of 25x squared. And so that would be positive or negative 5x. Okay? And last, never mind. This is not last. This is not last by any means, is it? Okay. So this is f dot g of 9. So we're doing same thing. F of g of 9 in this case. Okay? So f of g of 9, that's 2 times 9 minus 8. And let's go ahead and simplify that while we're here. 2 times 9 is 18, minus 8 is 10. So all we're doing is finding f of 10. So we have 3 over 10 minus 4. Or 3 over 6, which is 1/2. And of course it's going to have us go the opposite direction. So g of f of 6 this time. That's g of 3 over 6 minus 4. That gives us g of 3/2. So in g, we're going to put a 3/2 where we see x. So 2 times 3/2 minus 8. That's 3 minus 8, or negative 5. And now for the very last thing. Oh, no, next to last. Keep on getting ahead of myself. This one, we're finding f of g of x again, but we want to determine the domain. So when we're looking at the domain, we have to consider the domain of the original functions f and g too, because sometimes there's holes. So f of g of x will be f of 3x minus 2. So that's 3 over 3x minus 2 plus 2. Three over 3x or 1 over x. Okay, so we need to consider the domain of all of these. So first, let's look at the domain of f of x. Well, the domain of 3 over x plus 2, the bottom cannot be 0. So x cannot be negative 2. For g of x, 3x minus 2, the domain is all reals. So we're good with that one. And then what about g of f of x? Well, the bottom cannot be 0, so x cannot be 0. So the domain for the composition, we have to include both the not negative 2 and the not 0. Okay? So we've got negative infinity to negative 2 unioned with negative 2 to 0 unioned with 0 to infinity. And now, I promise you, this is the last idea. And that is decomposing a function. It's not as hard as you would think. Okay? So here we've got that h of x is the square root of 3x minus 7. And we want to find two functions that, when composed back together, would give us the square root of 3x minus 7. Like I said, it's not as hard as you would think. So we've got f of g of x. Okay? So f of g of x is the same thing as f of g of x. So what could be plugged in? The 3x minus 7. Because you'll notice if I'm careful with my color coding, that the 3x minus 7 goes in the square root. So what this is telling us is that g of x is 3x minus 7, and f of x is just the square root of x. Notice if we took 3x minus 7, stuck it in f of x, we'd get the composition of f and g, which would be h. And one more example like this. F of g of x needs to be x plus 1 cubed. Well, what can we do? If we make this the cubed part and then plug in the purple, that's telling us f of x plus 1 would be x plus 1 cubed. Okay? So that's saying that g of x is x plus 1, and f of x is, what's left? X cubed. And that's the end of section 1.8 and the end of chapter 1.